Hi everyone, my name is Vikas. I am from CSC AML Section D, uh, where I take the topic in chemistry, the multiple tube method. And I am going to the topic, introduction to multiple tube method. The multiple tube method is a qualitative and semi-quantitative technique used to detect and estimate microbial contamination in water and other fluids. It relies on a statistical principle to infer the most probable number MPN of viable microorganisms in a sample based on growth patterns across multiple test tubes. This method is widely applied in environmental monitoring, food safety, and public health due to its simplicity and cost effectiveness. Unlike direct counting methods, it does not require expensive equipment or advanced imaging systems, making it accessible for routine laboratory use. In engineering chemistry, it supports water quality assessment, especially in industrial effluents and cooling systems relevant to aeronautical environment. Principle behind Principle behind the multiple tube method. The method is based on the dilution to extinction principle, where a sample is serially diluted and inoculated into multiple tubes containing growth medium. Each tube is observed for microbial growth, typically indicated by turbidity, gas production, or pH change in the medium. The pattern of positive and negative results across dilutions is compared to standard MPN tables to estimate microbial density. Statistical confidence in the result increases with the number of replicate tubes used at each dilution level. This approach accounts for the probabilistic nature for microbial distribution in concentration. This is the principle behind the multiple key component and reagents. Lactose, both are broth or other selective media, is commonly used to support the growth of coliform bacteria in water testing. Durham tubes are included in each test tube to detect gas production, a key indicator of fermentation activity. Multiple dilution levels are prepared using sterile saline or buffered water to ensure accurate sample distribution. Replicates, typically 3 to 5 tubes per dilution, are used to improve statistical reliability and reduce random error. Incubation is carried out at controlled temperature, example 35 degrees for 24 to 48 hours to optimize microbial growth conditions. And this is the key components and reagents. Procedure step by step overview. Being with a representative sample. Example 10 ml of water and perform serial tenfold dilution using sterile diluent. Inoculate measured volumes 1 ml, 0.1 ml, 0.01 ml from each dilution into sets of replicate growth tubes. Include positive and negative control tubes to validate media sterility and growth, promoting ability. Incubate all tubes under specified conditions and observe for signs of microbial growth after 24 and 48 hours. Record results are positive or negative for each tube to every dilution. Another slide, the interpreting results using MPN tables. Results are compiled into a combination of positive tubes across dilution levels. Example 5 3 1 for 5 positive at 3 at 10 at 10 3. Oh, this combination is cross-referenced with standardized MPN tables to obtain most probable number per unit volume. MPN values are estimates with associated confidence intervals reflecting the inherent uncertainty in probabilistic methods. Higher replicate numbers improve accuracy as they provide more data points for statistical modeling. Results guide decisions in water treatment, such as whether disinfection or further testing is required. Advantages of a multiple tube method. It is highly sensitive for detecting low levels of microorganisms, especially in dilute samples. The method requires minimal instrumentation and is cost effective for routine monitoring in resource or limited settings. It can be adopted for various it can be adapted for various microorganisms by changing the growth medium and incubation conditions. Statistical robustness increases with the proper replication and dilution design. It remains a standard method in regularity testing, such as EPA and WHO water quality guidelines. And this is the advantage of multiple tube method. Limitations and the sources of error. This method is a time consuming, requiring 2 to 5 days for completion due to incubation periods. It provides only an estimate, not an exact count, and has wide confidence intervals at extreme dilution levels. False positives may occur due to non-target organisms that ferment lactose or produce gas. Inhibition of growth in high concentration tem- samples can lead to underestimation if dilution is insufficient. Subjectivity in interpreting weak growth. Uh, the method is time consuming, requiring 2 to 5 days for the completion due to incubation periods. It provides only an estimate, not an exact count, and has wide confidence intervals at extreme dilution levels. False positives may occur due to non-target organisms that ferment lactose or produce gas. Inhibition of growth in high concentration samples can lead underestimation if dilution is insufficient. Subjectivity in interpreting weak growth or gas formation may introduce observable bias. Unlike membrane filtration, these are comparison with alternative methods. Unlike membrane filtration, which allows direct colony counting, the multiple tube method is indirect and probabilistic. It is less precise than plate counting, but more stable for samples with a very low microbial loads. Compared to PCR-based techniques, it is lower, but it does not require DNA extraction or specialized equipment. It remains valuable where rapid molecular methods are unavailable or cost prohibitive. However, it cannot identify specific microbial species without further biochemical testing. Application in aeronautical engineering context. In aircrafts, the method can assess micro. By aeronautical engineering context, okay, role in AMA integrated monitoring systems. And these are future directions and innovations. Automation for inoculation and reading process is reducing human error, increasing throughput. Digital MPN calculators and mobile apps will now provide instant statistical analysis and confidence intervals. Hybrid approaches combine traditional MPN with the rapid detection methods for faster preliminary screening. Research is exploring microfluidic adaptations of a method for miniature eye through testing in AI-driven labs. The method serves as a ground truth data set for training predictions models on microbial behavior. Thank you.